Today's data show is going to focus on climate change. Stay tuned. Right now is the data show. Climate change, it is so provocative. It evokes such emotion that it's very difficult sometimes to see the forest from the trees. Climate change is here. I get it. I would be the first one to tell you that climate changes. Absolutely. Hi, I'm Chris Greco. For the next 30 minutes, we're going to be talking about climate change in the data show. I want to make something very clear here, though, when it comes to climate change. Climate has always changed. Climate is changing. It will always change. It is always part of the changing aspect of the Earth. That's just the way it is. You know, as a pilot, as a private pilot, I can tell you that, you learn different things about weather, and you learn different things about all the other aspects of have to do with weather. And one of the things that determines weather is the sun. The sun is the thing that determines weather. Winds, pressure, everything is determined by the sun. So therefore, as the sun gets older, no matter how much older it is going to change. If we put more stuff up in the air, more particulates, whatever else, more area is going to be reflected from, the sun's rays are going to be reflected. There's going to be a change. And I think this is really important to go at from the standpoint of climate change, is that, everything is being blamed on climate change. Everything is being blamed on climate change. So let's take a look at the things that can be blamed and those that can't. But before we do all that, let's talk about climate change to begin with. And I think this is really, really important from that standpoint. And the U.S. government has plenty of sites out there. So I've collected some data. I'm going to show you where I get the data. I'm going to show you where you can get the data. And then you can go ahead and you can analyze it the same way I analyze it. But the one thing that they do not mention at all in any of these areas, although I shouldn't say that, they don't mention it all. They do mention it in a brief area, is called what I call the Bayesian factor, right? The Bayesian probability. And I've covered this before, and I think it's very important to understand that when we talk about different aspects, or we talk about those areas, we talk about where we are from the standpoint of Bayesian. So if we take a look at these situations, and we take a look at, let's say things like how do we collect the data, right? How do we collect the data? What do we do? How does it work? Well, all these things, change. They just plain old change. And they change because of Bayesian. And Bayesian probability took into consideration when we talk about this, we talk about the Bayesian probability aspects. And that basically is that things change. And those changing factors should be placed into the data collection and the data analysis to make sure that people understand the limitations of that data collection. So that's pretty important. And I think it's something that really needs to be driven home, is that some of this data that I'm going to show you has been collected since 1900. Great, right? Super, fantastic. Well, the problem is that when you collected weather data, you had no satellites. In fact, there were no satellites other than the moon around the Earth until the late 1950s. That means for 50 years, all weather was collected from the surface, or through what they call weather balloons. When you put up the balloon and then you take the readings off the weather balloon. Of course, they have to, get the. It wasn't like they had wireless. They couldn't really. They have to bring down the balloon. They have to read the balloon, the instruments on the balloon, those types of things. So it was a very, very interesting situation. They have to have it wired or something to be able to get that data. So it was archaic, but to tell the truth, from the 1900s on, it was actually not bad. It was not a bad way of collecting data, not a bad way of collecting weather. And for farmers and stuff, it was really important for them to understand, weather and different aspects and predictions and those things that come about. So that's what we have to remember, that the Bayesian probability. Bayesian probability is kind of interesting because we're talking about UFOs today and UAPs and those types of things. And, Bayesian would be, he'd be laughing. He'd be, doing all kind of probability aspects, because his thing would be, the reason he did this, he was a theologian. The reason he did the probability aspect was to try to prove miracles. And that's why he wanted to, show the probability of something was so small that the only thing that could have happened, was, other than coincidence, was basically a miracle. The things came together, the confluence of events, whatever you want to call it, because of that. And that's why they called it that. So let's go ahead and talk about the climate change indicators. So the first place I want to go to is the EPA. The Environmental Protection Agency has some really, really great data on climate change. So the first thing we're going to talk about is U.S. and global temperatures, but we're going to center in on the U.S. for this point in time. You can change this up. There's your figures worldwide, right? So this is worldwide. This is temperatures in the U.S. And you can see here, just from here, the temperature anomaly, right? We're talking less than 2 degrees Fahrenheit here, all right? 2 degrees Fahrenheit. Here we're talking about 3, maybe 3.5 degrees Fahrenheit now. Now think about this for a second, folks. Charts are very powerful. They're a very, very powerful thing to see. We're talking 3 degrees. 3 degrees Fahrenheit, okay? Temperature anomaly. 3 degrees, okay? That's, but I just thought I'd throw that out there. You just can't look at this and all of a sudden say, oh my gosh, look at this. Look at what it looks like. Oh my gosh. And then you take a look at it and say, well, wait a minute now. It's 3 degrees, a little bit more than 3 degrees anomaly here. So that's what we have here, right? And then there's a big difference. We have here Earth's surface. The Earth's surface is here, red and blue. So this is measured from the Earth's surface. This is measured from what they call lower troposphere, and UAH and RSS. And I think, if I'm not mistaken, the UAH and RSS represents 2 different methods of analyzing the original satellite measurements. Okay, so there's 2 different methods here. Pretty close, though. They're not bad. Not bad. They're pretty doggone close. If you see the yellow and the green, they are relatively. Let's get this a little bit. There you go. So that's not bad. Look, I trust the U.S. government, and a lot of people sit there and say, I don't trust them. Well, I trust them because they are, especially in data recording, I've never seen them where they're not transparent in data aspects. They'll tell you where the limitations are. So that's what I have. In fact, I have a couple of Excel spreadsheets, and I'm going to bring these up here. So this is the, I took the data and I put them in some charts. So I'll show you the charts here. So this is the satellite measurement here. And what I'll do is I'll make sure that you get this. This is what we'll do is we'll make sure that we get this here. The share screen thing has been kind of wonky for me, so I'm sorry about that. So we'll go ahead and kick this on, and hopefully it'll come up here in a second. But the Excel spreadsheet is pretty important because it shows, I wanted to put on just a very simple linear regression analysis to be able to figure out what's going on there. And I think that's pretty important from that standpoint. So we'll see what we can do to be able to make this work for you. So, but like I said, share screen been kind of wonky, and not real happy about that either. Because dadgummit, come on, guys, just let's go, get this thing moving here. It's kind of bumming me out. So the well, let me just describe to you what the chart shows. So it's very evident that the StreamYard is failing me here. So basically what's happening is that they had the I put in the chart, and the chart shows that there is an up-down movement over the years from about 1979 all the way to 2020 for the satellite measurements, right? Satellite measurements, and this is pretty important, because I mean, if you don't have that, if you don't have an up and down movement, then something really is strange. So there's got to be when we talk about it, when we talk about the different aspects, we want to make sure that we talk about those that those that make a difference. And I think this is important. So great, finally. Okay, so this is the Excel spreadsheet, and you'll see when it finally comes up, you'll see that basically what happens is that you have the ability for There it is. Whew, thank goodness. All right. So this is for the satellite stuff. Remember the UAH and the RSS, the two different methods of doing it. So this is from 1979 because that's when the satellites came into play. Again, we have to take into consideration the different measurements here. Okay, so very important. But you see, they go up, down, up, down. At one point, there's only one measurement from the satellite, only one. Here, where it's slightly negative. In other words, there's been a negative negative temperature anomaly. The rest are all positive. So think about that for a second. This is troposphere, which is where most of the weather occurs. And then we have, so what I did was I put in a regression line. You can see it here. What I'm going to do is I'm going to, let's put this in so it's a little bit more solid. We're going to do red because red is, bad or whatever you want to call it. Compound type, we're not going to have any dashes. Come on, let go. We'll have a solid line, and now you can see. So there you can see, look at it. It's coming up, right? The temperature is coming up. Understandable. I get it. Okay, temperature is coming up. So we sit back and we go, okay, that's one of them here. Now the other one I want to do is, first I want to get this out of the way here. In fact, let me get it way out of the way. And then we want to show this one. So this is the weather from the Earth's surface here. Okay? This is the weather from the Earth's surface. Now you see here's plenty of negatives here. Plenty of negatives on the Earth's surface. And that is that when we talk about, in fact, let's move this. Let's move the chart to another sheet, to a nice sheet so you guys can all see it. And so there it is, right? In fact, let's bring it up here. Let's do this. And let's go there. Now, if you take a look at this, you'll see that again from 1900 to 2020, I think it's 2021 or 2022. You see there's this climb. So there is a climb, there is an increase in temperature on the surface. But again, look where this is. 3 degrees, 2 degrees difference. Okay, 2 degrees anomaly. I mean, this is over a year. This is over a year, folks. Boom, up here, down here. So there is a slight increase in temperature. So climate change is it's not something that's false. It is something that is taking place. So I mean, we take a look at this stuff. So let's take a look now at wildfires. So here are wildfires. Now everybody says wildfires. Oh my gosh, wildfires so bad. They're the worst they've ever been. They're so bad. Well, no, they're not. Here's the situation. Here's 1980, about 1983 when it started, about 2021. Now take a look at this. This is the regression line, which basically shows kind of an average. The average means that this is a straight line, which means there's not much difference between one year and another, even though it looks like there is. And again, this is simple linear. This is a simple linear regression. Okay, it's just that's just the way it is. But look, it's a straight line, folks. 0 means there's no difference. I mean, this means that yes, you can see the difference as you see here, but there's no real. I mean, yes, this is the this is 2018 here, right? And this is 2020 here. So this is the fire center. This is National Interagency Fire Center, and this is what they're reporting. So I mean, this is maybe we're getting a better control over them, and maybe that's the issue, and maybe that makes it better. But this is what you're talking about. So I'm not making this stuff up, folks. I'm not making this stuff up. This is the National Interagency Fire Center. This is where I got this. It's not some fakey thing. And this is it right here. EPA's climate change indicators in the United States, WP. Here's the site right here. In fact, we'll get this up so you can see it. There it is right here. Data source, web update, July 2022, units and number of fires. So, I mean, again, these are number of fires. Forest Service wildfire statistics is here. And you can see these are much greater then the national, this is 95,000 here. They're saying is units, number of fires. They're saying 18,000 here. So, I mean, they're saying 118,000 here. They're saying 20,000 here. So that's, if you have two different reporting functions, then you may have two different reporting data, and that data is very important to differentiate. So this is just the national agency, interagency fire stuff. So let's say just for the heck of it, I'm going to go ahead and just do just do this area from 1997. And let's see what I can come up with here. I'm going to just go ahead and do this. I'm going to insert this and do a, I always start out here, and then I make it work, because it won't always take the dates. Sorry, Excel. Thank you, Microsoft. So so that's what we have here, and we'll do this, and we'll do solid line, and we'll do the marker, and we'll do none here. Now this will come up in red, which is good, actually, kind of fire red, that type of thing. So this is what the statistics show here. So let's say if I were to add a chart element, let's say I were to add a trend line, and I would do a linear trend line. Well, according to the linear trend line, now this is linear now, the fire service wildfires are actually decreasing. The numbers here are actually decreasing. They're slightly downhill, which means as one increases, the other one decreases. So as years go up, the amount of wildfires come down. And this is just the United States. So take a look at this and say, okay, look, if I'm going to do data and data analysis, it's a very simple analysis. But this is data. I'm not making up this data. This is data I'm getting. All I'm doing is putting it against linear stuff. Now, if I want to do anything else, let's say I want to do if I want to do another type of linear area, then I could do like a polynomial, which would show, again, it's going down, logarithmic down, power down, moving average, just the moving average, it's coming down. So, I mean, all these things, even if I do exponential, which is an exponential trend line, which is good, that's actually a very good indicator. Again, everything is down. It's down. So for us to sit there, now again, this is only till 1998. This is only till 1998. So that is pretty important. I think it's something that you need to, we need to take a look at from that standpoint. And this is what it looks like. So I mean, it's not something that I sat there and said, okay, they're wrong. Look, this is data that's collected. I'm not going to say no, they're wrong in the collecting of data. I'm just saying that the analysis of it, the media is all about look at the amount. Well, I'm looking at the amount. I'm looking at the amount of fires. I'm looking at the amount of wildfire frequency until 2021. I'm sorry, but till 2021. Now, if you're telling me in the last 2 years that they've been absolutely astronomical, fine. I'll wait until that data comes out. Again, this is from the EPA. They're kind of backlogged, and I get it. I really do understand. I used to be in the government. I get this stuff. So as soon as 2022 comes out and 2023 comes out, because it's July 2022. So I mean, I guess this month will come out with the 2022 area, and they'll add that on there. But you can see, up until 2021, just the number of wildfires just show this straight line. Now, could they come up a little bit? Sure they could. They could come up a little bit. Right now they're stable in 2021. If they shot up, it could make a difference in this, that it could show an increase. Shows an increase, then that's all, that's cool. But again, this is 2021, right? So that's it with that. So now what I want to do is I want to make sure that we have, so that's that. And I think that's important. So what I'm going to do is I'm going to go ahead and go back to the climate share thing that I just had. We'll add that on there. So, I mean, there's so many good things in here. I mean, since 1921 on, 48 states, risen average rate of 0.17 degree Fahrenheit per decade. 0.17 degree Fahrenheit per decade. Okay, average temperatures have risen quickly since late 1970s. Again, late 1970s, what do we have here? We have this lower troposphere measured by satellite thing, right? But in addition, you have the Earth's surface. Now, the thing that I like, the thing I really like them about them is this. Data from the early 20th century are somewhat less precise than more recent data because there were fewer stations collecting measurements at the time, especially in the Southern Hemisphere. The overall trends are still reliable, however. I mean, I get it, but to sit there and say they're reliable in the face of changes in technology, different measurements, different accuracy, all these things, I don't know. It says the data has been adjusted to account for any biases that might be introduced by factors such as station moves, urbanization near the station, changes in measuring instruments, and changes in the exact times at which measurements are taken. Good. I'm glad they put that in there. That's good. That's called total transparency in the data. I like that. That's good. You know, good for them. Now, does that account for all the changes? I mean, the Bayesian probability aspects, probably. In fact, I wouldn't doubt if they used some of Bayesian aspects in this area and quantification to make sure that they had it as good as possible. But again, that still comes out to say that I still got a straight line. I mean, it's you know, once you get a straight linear line, I mean, there's not much difference. I mean, that shows, in fact, statistical significance would mean that it is not statistical. There's no statistical significance, no difference. So that's, I mean, that's just coming into that statistical analysis aspect. And you guys can check on this. Check me, man. Confirm that I'm good. If I'm not, dadgum, I've been putting this thing up since day one practically. Email me, tell me, hey, Chris, you're full of crap. I'm good with that, and then show me why. Don't just tell me, show me why, and I'll be more than happy to put that on the next show. So email me, hey, that's fine with me. It doesn't bother me at all. I mean, so this is what this is. Now, data sources, I went to this area. This is assessing, this one is assessing the U.S. climate change in June 2023. This is also very good. NOAA, National Oceanic and Atmospheric Administration, fantastic. Climate Aspects, NCEI, they do a great job. I mean, really seriously, the National Centers for Environmental Information. So them, I'm sure they work hand in hand with the EPA. So this is also a very good site. I'm going to go ahead and I'm going to put this on here for you so that you have it, so that you can take a look at it if you want to take a look at it. 12 billion weather and climate disasters, temperature. Here's the temperature area, mean temperature departures from average. Again, limited. We had limited measurements back in the 1900s. So it's a lot of people are saying things like unprecedented. Well, no, not really. And prove to me, or this is the hottest that it's ever been in 120,000 years. No, false. That's unfalsifiability. I cannot prove that wrong. I cannot prove that wrong. We got to let that stand, because nobody can sit back and say, wait a minute, I can't, because I can't prove it wrong. I can't go back 120,000 years. And certainly, and they sit there and say, well, we do it by tree rings. We do it by other areas. I'm sorry, but that's not that 120,000 years. Nobody knows what happened 120,000 years ago. And I already said this on the worldview. I'm going to say it here. Nobody knows what happened 120,000 years ago. Nobody with any intelligent guessing whatsoever can figure out what happened 120,000 years ago. The best we can do is have this really wild, what we call WAGs, which were wild guesses, wild A guesses back when, right? Because you can't do that. It's unfalsifiable. I can't falsify that. If I can't falsify it, then I have no way whatsoever to try to say, hey, look, what's going on. I'd like to see all the data analysis, not the data analysis, the data collection. How did you collect this data? What method did you use? The reliability of that method? You know, I mean, carbon dating, it's already proved unreliable in situations. Tree ring counting, you know, cut me a break. There's situations where, yes, you can, okay, I can prove it because I counted this back 10 years or 20 years or 30 years or 40 years or 50 years and then confirmed it with data. There you go. That's good. But you cannot confirm 120,000 years ago with data. There was no data 120,000 years ago. It wasn't going to, I don't know how else to say it. I mean, people that say this, and scientists specifically that say this, you know, I challenge that. I challenge that right off the bat. Prove to me that that's 120,000 years ago. Oh, well, you know, this and this. No, wrong. That's one tree, one ring, or 20 trees, or 100 trees, or 100,000 trees. 120,000 years ago, there was different tectonic aspects. Things were completely different on the face of the earth. You know, I mean, and civilizations were few and far. You know, they were there, but you know, they were few and far between. I mean, people, I don't even know if they were concerned about weather at that point in time, which is probably, you know, things were happening because they were happening. So this is nice, and I really do appreciate what the NOAA and EPA and the rest of those guys are doing, because it's really, really important. But you know, don't try to tell me that 120,000 years ago this happened, right? And so, I mean, they're saying, period, 1895 to 2023. Again, the measurement of temperatures in 1895 are not near as accurate or reliable as they were in 2023. And if stations change, if things happen, then that's also a problem. Now, the last thing I want to go to is population density. This is actually really good. The population density is really cool stuff. And so, because this is important in the United States. So what I did was, again, I took the population. I've taken the population here. It's 331,000 in 2020. In 1940, and we'll go all the way back to 1940. I think I thought I had further than that. So there we go. Yeah, 1910. So 1910, there were 92 million people in the United States. 92 million people in the United States. Now at 330 million, right? 330 million. We had a 26 population density measured per square mile. 26 people per square mile. We are now at a massive, where are we? We are at a massive 93.8 per square mile. So this is the United States now. But what does that mean? That means that there's more people. When there's more people, then that's going to impact on the weather. Now, a lot of media loves this, by the way. Anything to panic and otherwise just put people in a divisive state, they just love it. Ask them what sells. What sells in media? It certainly is not, you know, the puppy, you know, the puppy adoption down the street. It is stuff like this, saying that, hey, look, you know, we're going to burn up soon, that type of thing. That's just, you know, astronomical. So what's happening is that, yes, there are more humans. Yes, these humans have to be housed. They have to be fed. They have to, you know, there's a lot of things that have to go on when a human is around. So by the nature of that, they are going to have a change in climate, because things are going to have to be produced. Things are going to have to be done. You cannot do this. You cannot produce this shirt. You cannot produce it except by hand. You can't produce a shirt without fossil fuels, because you have to be able to manufacture it. If you manufacture this shirt, it's going to take steel, and steel is produced. And I wanted to make sure that you understood this. This is from EPA.gov. It takes, and this is important, it takes a burner hood at the beginning of whatever this is doing steel, 1300 to 1480 degrees centigrade, 2400 to 2700 degrees Fahrenheit. That's what you have to produce steel. This is what you have to produce steel, folks. You know, I mean, 2.3 milligrams, 2.5 tons of raw material, including water and fuel, are required to produce 0.9 milligrams, 1 ton. So you have to have 2.5 tons of raw materials to be able to produce 1 ton of this sinter, which is part of steel production. So this is, it says fine sinter process converts fine sized raw materials, including iron ore, coke, breeze, limestone, blah 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 blah, suitable for charging into the blast furnace. That's just for producing sinter, and then iron, then steel. So, these things are amazingly. Like I said, here it is right up here. If you want it, there's your address right up there. You can check it on me. So this is what I want to talk about today, was just all the different factors that go in to this climate change aspect. Is climate changing? Absolutely. Absolutely. There's no doubt about it. Those people that sit there and say climate is not changing, look out the window. Climate changes all the time because weather changes. Weather goes into climate. And people are going to sit there and they're going to say, no, you're wrong. Look it up. Look it up. It's and I know all the scientists in Congress are going to sit there and say, I'm a scientist. Yeah, that's nice. But the bottom line is that just look at the definition. You got to have weather to have climate. It doesn't work. That's just the way it goes, folks. So on that note, I'm going to finish this off because this was a pretty provocative episode. So it'll be interesting to see the how it works on YouTube when we're about to put it in the different areas. But there's nothing false in what I've said. Take a look at it yourself, analyze it yourself. I've given you enough tools to be able to do that. And, take a look at it. And I'm going to tell you right now, this is what the data show is about. Taking a look at data, analyzing it, and making the decision yourself, finding out what is below the surface of all these media reports on data, climate change, and whatever else. This just isn't, it didn't even hit the topsoil of climate change. So let's take a look at what we have and let's find out what we need and then move on from there. And this is Chris Greco for the Data Show saying, thanks a lot for watching, and I'll see you next time.